Hello everyone, today we're going to look at defining the trig functions. What we do is we start with an angle in standard position and we choose any point on the terminal side. So I'm going to call it x, y. We define r to be the distance from the origin to this point. So r is this distance here. We can draw a vertical line from the point to the x-axis and think of this as a right triangle. And our right triangle would then have a horizontal leg of size x, a vertical leg of size y, and the hypotenuse of r. So we've got a right triangle right there. The 6 trigonometric functions are just ratios of the sides of this triangle. So things to keep in mind, the argument of a trig function is an angle, and the output is a number with no units. Remember, it's a ratio of two sides of a triangle. So I put in an angle, and I get out a value, just a straight up number with no units. The first trig function we look at is called sine, so it's spelled S-I-N-E, and when I write it in, say, math mode versus English mode, it looks like S-I-N, but remember it's sine, not sin. So sine of theta, remember it's a function like the square root of 4, sine of theta. And the sine of theta is defined to be y over r. So remember y was that vertical leg of the triangle, r was the hypotenuse. Another one is cosecant of theta. In math mode, it's abbreviated CSC, so remember it's cosecant of theta, and that's the reciprocal of sine. It's r over y. The next one is cosine of theta. In math, it's abbreviated COS, but remember it's cosine, not cos. Cosine of theta is defined to be x over r, so the horizontal leg divided by the hypotenuse. The next one is secant of theta, abbreviated SEC, secant of theta, is the reciprocal of cosine. It's r over x. And then we have tangent of theta, abbreviated TAN. So tangent of theta is y over x. And then the last one is cotangent of theta, COT. So cotangent of theta is the reciprocal of tangent, x over y. So these are the 6 major trig functions. The 3 over here are the functions that we have on calculators, and these ones are the reciprocals of these guys over here. So we don't need buttons for them on the calculator. We know how to take the reciprocal of things. So we don't need to clog up the calculator with these other functions. So again, sine, cosine, tangent on the calculator. Cosecant, secant, cotangent are just reciprocals of the other ones. These definitions will be given to you on the test, so you don't have to have them memorized, but you need to make sure that you're looking at the correct one. So we're going to do some examples of using these guys, and we're basically going to look at 2 different types of questions. So the first ones are given 2 of the 3 values, so x, y, and r. Can we find the third using the Pythagorean theorem? And we can. And then we're going to use those to find the other trig values. And we will never at any point actually find theta. So if the terminal side of theta goes through the point 3, 4, find cosine of theta and cosecant of theta. So in order to use cosine or cosecant, we need r. And in order to find r, we're going to use the fact that it's the hypotenuse of the triangle. So r squared equals x squared plus y squared. So r is the square root of x squared plus y squared. X was 3, y was 4, so it's the square root of 9 plus 16, which is 5. Cosine of theta, by definition, is x over r, which is 3 over 5. Cosecant, by definition, is r over y, which is 5 over 4. So we're given 2 of the values. We use the Pythagorean theorem to find the third, and then we just go back to the definitions and make sure we're looking at the correct ratio. So as another example, if the terminal side of theta goes through 24, 10, find tangent of theta and sine of theta. So then we're going to find r first. 24 squared is 576. 10 squared is 100. The square root of 676 is 26, so r is 26. Tangent of theta is y over x, which is 10 over 24. So notice I didn't even need r to find tangent. And I'll simplify that to 5 over 12. You always want to leave it exact if you can, because it's really nice. It's the exact answer. There's no question about it. It is 5 over 12. So leave it as 5 over 12. Do not plug it into your calculator and come up with a decimal for it. The next one is sine of theta. Sine is y over r. So that's 10 over 26, which is 5 over 13. Okay. And then the other type of questions we can have are the following. Given that sine of theta is a half, find cosine of theta and cosecant of theta. So I'm given one of the trig functions. Can I find the others? And for this case, we're going to assume, for simplicity's sake, that everything is in quadrant 1. So x and y are both positive. So we're not going to have to worry about being in quadrant 2, say, where x is negative, or quadrant 4, where y is negative. So just assume x and y are both positive for now. We'll see what happens if we're in other quadrants later on. So what we're going to do is we're going to use the fact that sine of theta is y over r. But we're given that sine of theta is a half. So we're just going to equate our top 2 numbers and our bottom 2 numbers. So we're going to let y be 1 and r be 2. And again, we're going to use the Pythagorean theorem, but this time I'm looking for x. So x is my unknown. So x, if I solve for it, is the square root of r squared minus y squared, which is the square root of 4 minus 1, which is the square root of 3. Again, I'm going to leave it as the square root of 3. I do not care what the decimal approximation is. Just leave it as root 3. And then we go back to our definitions. Cosine of theta is x over r, which is root 3 over 2. Cosecant of theta is r over y, which is 2 over 1, which is 2. So make sure you always simplify your answers. Don't leave it as 2 over 1. We know that that's 2. Let's try another one. Given that secant of theta is root 5 over 2, find tangent of theta and cosine of theta. So secant of theta is r over x, which is root 5 over 2. So again, equating the top and the bottom, r is root 5, x is 2. Pythagorean theorem, we're going to solve for y. Right, we don't have y yet. So y is the square root of r squared minus x squared, which is the square root of 5 minus 4. Remember, root 5 squared is 5. So make sure you're not squaring 5. It's your square root. It's the fact that you're squaring the square root of 5. So the square root of 5 squared is 5. And then 5 minus 4 is 1. The square root of 1 is 1. So tangent of theta, y over x, 1 over 2. Cosine of theta, x over r, 2 over root 5. And if you remember from Tech 1, we said that we don't like square roots in the bottom. So I could rationalize this if I wanted. And remember, to rationalize it, you multiply top and bottom by the radical on the bottom. So if I wanted to rationalize this, it would be 2 root 5 over 5. I don't really care. I don't understand why we don't want roots in the bottom. So if you leave it as 2 over root 5, that's perfectly fine. If you want to rationalize it, go right ahead. So either one, 2 over root 5 or 2 root 5 over 5 is perfectly fine. But let's try one more. Given that tangent of theta is 1, find sine of theta and secant of theta. So we know that tangent of theta is y over x, and I know that tangent of theta is 1, so I'm going to write this as a fraction. And 1 I'm going to write as 1 over 1. It doesn't matter what fraction I use as long as it's equivalent to 1. I could use 2 over 2, 4 over 4, pi over pi, 28 over 28. As long as it's equal to 1, it doesn't matter. So in this case, y and x are both 1. And I'm looking for r. So r is the square root of 1 plus 1, which is the square root of 2. And again, I'm going to leave it as root 2. So sine of theta is y over r, which is 1 over root 2. Again, at this point, I don't care if you rationalize it. You can leave it as 1 over root 2. Secant of theta is r over x, which is root 2 over 1, which is root 2. Some things to keep in mind. Remember that sine and cosine are the legs of a triangle divided by the hypotenuse. The hypotenuse is always the largest of the legs of a right triangle. So if I look at sine of theta, it's never bigger than 1. And the same is true for cosine of theta. Sine and cosine of theta will never be bigger than 1. Because again, it's the leg divided by hypotenuse. Hypotenuse is always bigger. On the other hand, secant and cosecant are the reciprocals of sine and cosine. The reciprocal of a number smaller than 1 is bigger than 1, right? I'm flipping it. So in absolute value, secant of theta has to be at least 1. And the same is true for cosecant of theta. It can never be smaller than 1 in absolute value. So these are things to keep in mind. As far as tangent and cotangent go, they can be any numbers. If we look at tangent of theta, remember tangent is y over x. Y over x is exactly the slope. Because remember, it's the, we know that one of the points is the origin. So y minus 0 divided by x minus 0. So tangent is the slope of the line. And the slope can be anything. It can be positive, it can be negative, it can be really big, it can be 0. So there's no restriction on tangent and therefore cotangent. But just remember the things about sine and cosine and secant and cosecant to make sure your answer is on the right track. So with that in mind, read through the book, try out the homework, and let me know if you have any questions. Good luck.